Hello, Professor. I hope you're doing well. I'm going to explain to you my Magnetorheological damper and how I've created it and how it works. So first, we're just going to go over the assembly. We have a linear potentiometer right here, which will record the piston position. It will then relay that information to the Arduino, which can read the resistance change and determine a piston position from that, which then will send a signal to this servo motor here. Through the Arduino. The servo motor will then rotate this dial resistor. This will change the resistance to the electromagnetic coil system over here. The electromagnetic coil system involves this 120 turn electromagnet, the resistor as we previously mentioned, and this 12-volt battery bank. In changing the resistance, what will happen is the strength of the magnetic field will change. If we just look up right here, this is the code that the Arduino is using. So as we see, the servo is attached to 0.9. And what it'll do is it reads the pot pin, which is from the linear potentiometer, reads that value, determines what value between 0 and 100 or 1023 corresponds to 0 and 180 degrees. So if the potentiometer is at 0 resistance, the servo will be at 0 degrees of turn. And every 15 milliseconds, it pulls a new reading. So just a quick demonstration of how this works. As this piston position moves, it is connected to the linear potentiometer and it reads this. So as you're saying, it takes that reading and then changes, and then it can rotate the resistance. The aim for this project is to increase the resistance of the damper as it begins to bottom out. So in theory, this is the damper and this is just a reservoir. So as that begins to happen, as we begin to technically bottom out the damper, the resistance for this will turn clockwise, which will increase the resistance or decrease the resistance and increase the magnetic field, which increases the viscosity of the magnetorheological fluid, therefore increasing the damping rate. So just a little quick demonstration as we go about. It's continuously changing the damping rate. So as we get closer to the end, it gets harder and harder to pull, and as we get away, it gets softer and softer. Thank you very much, and I hope you enjoy the rest of your day.